Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today, we are mastering LeetCode 236. Lowest common ancestor of a binary tree. This is a fundamental tree problem that tests your understanding of recursion and depth-first search. Let's look at the problem statement. Given a binary tree, we need to find the lowest common ancestor of two given nodes, P and Q. The lowest common ancestor is defined as the lowest node in the tree that has both P and Q as descendants, or we also allow a node to be a descendant of itself. Think of it like two explorers in a vast, branching forest. They both start at different locations and send a signal flare back up the trails they took. Each trail leads back to the main base camp. The first fork in the trail where both signals meet is their lowest common meeting point. That is exactly what we are looking for in this tree. To solve this, we use a recursive depth-first search. At each node, we ask two questions: did we find P or Q in the left subtree? And did we find them in the right subtree? If a node receives signals from both its left and right children, it must be the LCA. If it only receives a signal from one side, it passes that signal up to its parent. Let's dive into the dry run. Look at the screen. We have a binary tree with root node 3. Our targets are node 5 and node 1. We start our search at the root, node 3. We move left to node 5. Since node 5 is one of our targets, we found a match. We return node 5 back up to node 3. Now, from node 3, we explore the right subtree, starting at node 1. Node 1 is our other target, another match. We return node 1 back up to node 3. Back at node 3, we have received node 5 from the left, and node 1 from the right. Since both sides returned a non-null value, node 3 is the lowest common ancestor. We found our meeting point. Now, let's look at the Python code. We define our function lowest common ancestor. The base case is simple: if the current root is null, or if it is node P or Q, we return the root itself. This is the signal we send back up. Next, we recursively call the function on the left and right children. We store these results in variables left and right. The logic is elegant. If both left and right are not null, it means we found P in one subtree and Q in the other. In this case, the current root is the LCA. If only one side is not null, we return that non-null value. This effectively bubbles up the found node to the higher levels of the tree. If both are null, we return null. Looking at the complexity, the time complexity is O of n, where n is the number of nodes in the tree, because we might visit every node in the worst case. The space complexity is also O of n, due to the recursion stack, which can go as deep as the height of the tree. And that is the lowest common ancestor challenge mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.